without much further ado, I'll pass over to Mark Oliver, who will tell us what he has been doing research on and a little bit about his teaching.
Thank you very much. So welcome, dear Mr. Chairman, Professor Betkov. Welcome my committee, Professor Kala and Professor Prass. Welcome, friends. Okay, so in the next 30 minutes I want to present the current results of the Habilitation project, and I will give a brief overview on the relevant research, or a long overview on the relevant research, and a brief overview also on teaching and also on funding acquisition, because these are also important jobs for professors, and therefore I also want to briefly talk to you about this. My personal journey started in Tübingen, then I went to Technical University of Munich. I spent 11 years here actually, and recently I became a research director at IMT Atlantique in Rennes, and all of you are happily invited to visit me there. It's a very nice place. Okay, so I will start with giving a short introduction to the way I orchestrate the Internet of Things, because this is important to understand the main part of the presentation, which is the Habilitation research roadmap here, which has different goals that are on this plan here, and we'll visit them. Then I'll briefly go to the teaching highlights, to the funding, and also to community work in conferences, etc. Okay, motivation for my research. So the motivation for my research is the following. In 2008, when I started with my PhD, Apple released the App Store, and this was a tremendous change for software developers, because from this point in time, ordinary people could start, not only computer scientists, could start developing something for a device, something that entirely changes the functionality of those devices. In 2008, according to the Gartner hype cycle here, it was also the beginning of looking at the Internet of Things, and so I'm lucky because I started looking at this technology enablers here right from the beginning. Okay. So what is special about the App Store? I briefly told it already. So when you start a different app on this device, you have a different device. You have a gaming console, you have a controller, you have whatever you can imagine. And this creative potential unleashed also the creative potential of developers. So today we have lots of applications for these phones here, which is very nice. And so I thought, okay, programming the phone is very nice already because everybody has one, but it would be much nicer if in a similar way we could not only program the phone, but also program our physical environments. And these physical environments are so-called smart spaces that are enriched with sensors and actuators, and it's a fascinating playground. I'll come to that in a second. So a smart space, as said, is something that contains sensors and actuators and software control, and this is what I call an IoT smart space. What is important here is the software control and the interaction with the physical environment. So it's for the first time that we can run programs not only in the shell of this one here, but in our real physical environments. There's a lot of creativity because people can develop something here with the maker culture. We want to have software development. And the research I'm presenting is in the area of the software control. So I want to facilitate the software development for these environments as much as possible. And to do so, I have to overcome complexity. And for doing so, I introduce lots of autonomous management functionality, especially important security here. Okay, so how would it look like when we have an app economy for smart environments? Well, there are examples from the science fiction. So this one you might know from Star Trek. So people are choosing a program, and according to the program, the entire environment.
Sorry, gentlemen, but we're close.
The example is not 100% matching because this is just a holographic projection. But today we can already imagine that our physical environments could indeed transform into a different space based on a different software that is running. Okay, so the scientific evolution also matches this hype cycle, and also it's clear that we had mobile computing first, because when we look at systems, we have distributed systems from early on, then we had mobile systems, and then when we had pervasiveness support, which is basically interfacing the environment, then we have pervasive computing, and an important part here is middleware. And this is also the focus of my research. When we look at different computing dimensions, this is also interesting to see, because this is a development from the 1960s when computing started. Then a major change was computers at home, personal computers, and with the pervasive computing, mobile computing and pervasive computing forming ubiquitous computing, so the ability to program the environments, this is again a big fundamental change. And what is important here is, or interesting is, that this one is many people use many devices and they can do it everywhere in the environments. And this is what fascinated me and is still fascinating me, and this is why I'm still excited to work in this area. Okay, so focus is on enabling an app economy for smart environments for pervasive computing, meaning collaborative development of software. The major challenge is complexity, and there especially heterogeneity, the distributed character of these environments, and also having humans in the loop. Because obviously we do not want to have what happened in Odyssey in Space, for instance, where the computer took over the power over the people that normally should be in the loop. When we look at the Internet of Things today, we see such a thing. So we see many vendors, everything is distributed, functionality is distributed, and this is of course hindering the vision, because in the vision we would connect everything and everybody could collaborate there. And therefore a major challenge is overcoming this, and to do so it is important not only to focus on one domain, but different domains are affected. So the Internet of Things as connecting technology, cyber-physical systems as connecting the physical environment, ambient computing as software running in the ambience, and pervasive computing, which is a community where the use cases come from, where the things are implemented. Okay. The Habilitation project is structured into 3 lines. So the first is operating system for the Internet of Things. So this is all enablers that we can provide for developers to ease their job, and also to provide functionality such as security by design that cannot be circumvented. The next layer is service management, and there are also the services, and the services is something that developers have to develop. This is something that we cannot provide for the developers, because this is the creative part, so there they create what they want to do in the environment. But as we will see, we can do lots of things there to protect the services. And the third one is also research. So I research in education here, so I always combine this with education and also did some contributions in this area. Okay, so what is a smart space? So key insight is we have the physical world, then we have the cyber-physical systems here, so the sensors and actuators that interface it, and then we have services that do control. And the idea was, okay, what can we do to facilitate this? Well, we can take away lots of the jobs that all these service developers have to do, and this is providing connectivity between the services, managing access rights and similar things, and also managing the data for them. And as we'll see, this brings a lot of advantages in the further things that I will present. When we switch now to a technical point of view, so this is how it technically looks like. We developed software components here that manage the data and provide access control and other things, resilience, scalability. The services are not talking to each other anymore, but the services are talking over this abstraction here to each other. It provides location transparency and so on. And this enables us to do very interesting research, because this gives us full control over the communication between these entities here. Yet another view. So this is another view of the same system. When you're a software developer, you can imagine the system as a tree of data. This tree is representing the environment, so all the software and hardware situation that is currently there. And through the system, you can discover information, access it, and change it. And what the developer has to do then is to provide a mapping between the physical phenomena and the virtual representation here. That is often also called digital twin of the physical thing that we have here and the phenomena that we measure. More to that on the next slide. Another interesting thing is that we see that it's very easy to program because it's very close to pseudocode what we see here. Okay, so digital twin aspect. So this one here is representing all relevant properties of the environment that we need. Another aspect of the digital twin is often that it's also simulating the behavior of the physical entity behind. This is something that is not provided inside our system, but that can easily be implemented with the services that are connected to the system. Advantage of the system is we have rapid prototyping, fully labeled traffic, a trusted domain in the middle, and we have full system knowledge as we designed the entire system. Okay, now we come to the research. So we have 7 items here that are the goal of the Habilitation project, and I will now go through them, so some of them a little longer, so some of them a little shorter. We can go into them afterwards in the questions, and I will always present briefly state-of-the-art, contribution, details, publications, and thesis. So this is also what you have in the reports there. And the main focus will be on these aspects: data modeling, security as key aspect, service and data discovery, and service security. Okay, so starting with the data modeling. So this is still a major issue in research and also for practitioners. We have different representations for entities, and this is something that has to be overcome. And the contributions that we provide here are, first of all, that we have a modular way of creating these representations. This brings advantages for the discovery, as we'll see, and it brings advantages for those that are creating the models because it facilitates the task significantly. Plus, we can validate things, and we are currently working on editors, for instance. So Florian is sitting here, who's doing that at the moment, and have user studies that are running here. So this is the system I've shown before. So this is one of these knowledge management components, and the key insight here is that we have a repository. In that we can define parts of things that we want to model as digital twins here, and we can reuse components. And this is very important. This is what the next slide shows also. So we have building blocks and we can recompose them to bigger building blocks. And this is advantageous because it means when someone is modeling a light switch, for instance, someone else can use the same light switch component in a different context. And so breaking the big data models into smaller parts that can be reused is a key insight that we have here. Okay. Good. So we have 2 publications, several theses that are ongoing in that direction. Next aspect is data security. And so this is a very central aspect of the thesis. So in deployed systems, there are standard security mechanisms that are used, like TLS encryption or tokens for access or password logins. In research, there are also research, so SmartM3 is the closest research, where data managing components are access protected, but still there they do not go through the whole cycle of information processing here. And so we have different contributions. So first of all, we authenticate all components, all the services and all our platform components. We encrypt the traffic. We have a mandatory access control. And at runtime, this mandatory access control that is group-based here on nodes can only be restricted. That means by design, we bring a certain access control that cannot be circumvented. And this is a major contribution here that goes beyond what the other systems are offering. At the same time, it's sometimes not enough, or it's typically not enough, because when you think about, you have a software that someone developed, and you ship it to your space, and then you run it. Of course, you also have local preferences that determine what you want to do. For instance, no one should be able to access my camera in the bathroom, and this requires local information. Therefore, we put, in addition, a policy-based access control there that can use local context. And we also looked at how we can fuzz data, so how we can say the software can know my location, but only to a granularity of certain kilometers or something like that, which is also helpful to prevent a spreading of data that I do not want to spread. Okay, so this first visiting of the security, we will visit it 2 times later again, is about the middleware. And so we, as said, we are running the middleware, so we control what is happening there. And that means we can protect the data, we can protect the communication, and we can protect the discovery. And this is very important because it means when we allow third-party people to develop something, they cannot break the properties that we want to enforce there. Okay, so what is important for the data access security now here is we have the service development chain here. So on the right side, we have a developer who creates a software, then this software is put into a store that is used for distribution, and then it's shipped into a space, and there it's put then to a compute node where it's executed. What's important here now is that the developer is, so the data is always authenticated and integrity protected on the entire process here, and so the developer already defines the access groups that are later used in the installation here, and then this is shipped here, getting signed again, shipped here, and then put to the node. Signed locally, the user can, as you can see here, only remove some access rights, so the user can never add additional access rights. And that means the developer already defined the access possibilities of the software, and it can only be restricted on the way. This is very important. When we have the local additional preferences, they are enforced and decided within the local space here. Okay, and so the data is instead this metadata that we see here. We'll see this picture a little bit later again when I come to service security. When we go now to this perspective, it means that we have a group-based access control feature plus these policies on all these nodes, so we have a fine granular access control to the data of the space. And the data is everything that is interfaced by other services, and that means we also have full control about the access in between services through this control that we have here. Okay. So in this part we also have different publications and 2 PhD theses that are running in this area. Okay, next point, data and service discovery. So the situation there is when you want to have dynamic binding, that means at runtime different components should be able to couple. You somehow have to discover them. And typically directories are used for that with predefined attributes. But to us, this is not enough because the IoT lives with its applications. And therefore, we created a modular discovery mechanism that can use any contexts, so any information that is locally available, and not only this that is predefined. And how does that work? Well, the concept is quite simple, but it's only working because of the abstraction concepts that we're using there, namely of having these digital twins with additional attributes. And so inside the system, we have type IDs that can be used for discovery here. So we can say, I search something of a type lamp and I will find it. And so now it would be nice to have more attributes, but the attributes cannot be defined by the developer because the developer does not know that you have a bathroom, for instance, or that you are called Janet, for instance. And therefore, these are things that can only locally be added. The problem with traditional ontologies is that you have to foresee at least the fields to fill them then at runtime. And so we decoupled this functionality into different modules here and added databases actually for different properties that we have here. And now you can query for all these properties. And you can also combine the query, so you can say you search for something of type lamp that is inside your living room and that is owned by me, for instance. And so this is shown here. So we have the different databases plus a provider that allows you to do intersections of the returning sets of the search queries that we have here. And this is a very powerful mechanism because it allows us at runtime to extend the search criteria that we have in here and to search for that in short time. Okay, also here again, different metrics that are contributed. Caching, there I only want to briefly go to it. So we have a data-centric system, and in data-centric systems, caching is always an issue. Therefore, there is lots of research in the caching area already. We looked a little bit at how can we use machine learning in order to classify which data should be replaced or which data should be cached in different situations here. And therefore, the distinguishing element to the state of the art is basically that we have different traffic that relies again on which applications are talking to each other, and therefore the result so far is that we do not have a standard mechanism that is always working, but we can observe what is happening and then do some caching. Picture is here. So we have different nodes that are running here, and we can place caches in different areas and have then obviously advantages in the availability and also in the latency that it takes to access information in here. Challenge is, of course, always knowing which is the newest data that is available. Having cached copies in the system is not a problem. The system will automatically find them, but you cannot be sure which is the newest element that is currently stored. And there we also don't have an answer yet. But we can always say, okay, when you are from at the source, then you will have the newest copy. Okay, and the last point here, low latency communication. So this is an interesting problem because when we are in these data-centric approaches here, then you normally don't have direct coupling between services. The good thing is in this system, we already have a mechanism that is called virtual nodes. And this is basically you access a data item here, but it's answered by the next service. So you have a connection in between here. And so what was missing, what we looked at is how can we do that in case we have here multiple hops where software is connected. And this is exactly what happens in here. So we can now say this one wants to talk to this software, and then we have socket connections that are terminating in our intermediate points here, and then terminating in the end. And therefore it's possible to stream now between the entities here. So we looked at this in different flavors. So having this multi-hop or also having a single hop, because our systems are often in a way that the services could talk directly, but we do not want this to happen, because at least not if it's outside of our control, because as said before, the system enforces the access control. And if we don't have control over who is talking to whom, then we cannot do this access control enforcement, and this would highly diminish our security properties that we have inside the system. Okay, good. That brings us now to the services, and we revisit the security now from the service perspective. So, yeah, what is important here is the properties I said before already, plus we did something towards learning the functionality of software for doing anomaly detection afterwards. Okay, so this is the picture we've seen before, and so what is important here is we have a hash over the executable, so we check the integrity of the executable the entire time. We can also check it when it's running here. This prevents changes in the executable there. And we can validate all the data in the system, which is very good. We have the secure properties for the access control here. And we also have a logging of who developed that, so we can always check who's the developer because of the key material that is part of the entire deployment stack here. And the software is protected from the beginning to the end with X509 certificates in here. Interesting aspect is also that we can change the access rights in here and do that by having another set of certificates where we can have the change properties, but can still do validation in the end nodes, which is very helpful. Okay. So here, the access we already looked at, because the access control is happening through controlling the data access. And the big open issue is the functionality. So software developers are creating the functionality of the services. Ideally, they would provide us a formal specification of the services. But naturally, this is not totally easy for people to do. And therefore, one way would be to automatically generate it. A way we looked at here is how can we automatically create such models of the service functionality to do anomaly detection afterwards. More in detail is that we want to sandbox the applications when we know what they are doing, so they are sending every 5 minutes a message. Then we can say, okay, in your sandbox you're only allowed to send a message every 5 minutes. If you do something else, then this is an attack, or it's a misbehavior, so we want to prevent that. But for that we have to know what is the model of the service here, obviously. And what do we do there? Well, we look at this black box service that we have, and do passive traffic monitoring, so when is it talking to whom. The advantage here is that we have fully labeled traffic, so we know who talks to whom and we know what they are exchanging because we are the platform. And this allows us then to do behavior modeling of the software. So we can create a model, when is it doing what, and then we can do anomaly detection. And firewalling, for instance, as one of the countermeasurements, or at least notifying the user, okay, something strange is happening. This is an example, so this is a demo we showed in Taipei last year, I guess. And so here we have a washing machine, it gets a software update, and when you click on the software update, it suddenly starts opening the front door, which is something we obviously don't want. And then we started this learning, and in our example, not surprisingly, it worked, it's prevented that this happens. Another interesting aspect is that we can share the information with other spaces that are running the software, and therefore we have a joint learning of the functionality. So we have better ground truth because more sites are creating informations in that direction. We looked at two aspects, so we looked at who is talking to whom, so there you can create a graph. The good thing is that you can also decouple. If a service is talking to 5 other services, you can decouple that because you know that it's the same kind of services. And the second thing we looked at is periodicities. So there again, we could decouple the traffic, do clustering, and then we knew, okay, these are periodicities for certain function calls. And this is also ongoing work looking at, okay, can we have more properties that we can automatically model? Okay, good. Then the other two aspects also only briefly. So optimized service placement. So when you have third-party developers, you somehow have to place the services. The idea is that in the environment, we have multiple compute nodes that we can use because they will get more powerful over the time. And therefore, it's interesting to do service placement and also update management as an important subset of it. And so this is also a problem that is well known. We chose a little bit different aspect from what is typically done, and we're not using Docker containers, but we're using OSGI bundles that are a little bit more lightweight to start and stop functionality in here. And besides that, we have similar problems, but maybe a little different infrastructure from cloud computing, for instance, or from sensor nodes, because the IoT is again heterogeneous in the availability and also in the links. And this is interesting to look at if the same optimization algorithms are working there. This is also ongoing at the moment. Okay. Deployment, as said at the beginning, developers store them then to the spaces. Inside the space, as the components are not interactive, so the users do not have access, so they are unattended. Therefore, everything has to be automated. And we have a head inside a site, and then on each node we have a local manager that are autonomously responsible for keeping the software running that was deployed to each of the nodes. We have some properties here, so most important is that it must be autonomous here, and yeah, so this is what we did here. And the update management is also important because, again, you have unattended nodes, so you deploy something and you have to make sure that after the update the software is still running. And therefore it's important that you have the rollback possibility so that if it's not running, you check that and then you can return to the last running state afterwards, because no one will want to unmount something that is in the wall, for instance. And so this is also something we looked at. And also how can we migrate the data if we have a new data model that is used here. And yeah. Okay, good. Okay, then I also consider it important to get into contact with a general or broader audience and also with non-computer science partners. This happens in projects, meetups, and so on. And so this is, for instance, a talk series where I interview different people about the effects of the digital transformation. And yeah, so this is, I just wanted to mention that because I also consider it important not to be just in one own domain, but to get out and talk to people about it, to get some input, because the digital transformation is touching everybody, and so everybody should be informed to exchange ideas about it. Okay, so teaching. So I'm teaching since 2003. And yeah, so this is just briefly, so I also got the Ernst-Otto Fischer Award in 2013. And yeah, I also had things of different sizes. So But also a bachelor lecturer, I was involved heavily in 2008, for instance, and different other formats with lots of people that I was teaching to in the past. I'm very experienced in all the formats because I was organizing all of them, because like teaching is a big passion of me, and so I was always curious to get to know new formats. And also have the Zertifikat Hochschullehre from ProLehre, which is also important in the habilitation process. Yeah, this is a little bit the teaching map. So most of my teaching is in English here, as you can see here. And all the yellow buttons here is something where I created a new format that was not existing in my surrounding before, or I did major changes at the format. And so many of the courses are still running here. Yeah, let's get a little bit quicker here. So I had more than 150 students in my career here at TUM. In the lab courses, which is was one of my major responsibilities, we had more than 2,000 participants in the past. And I just briefly wanted to talk about some highlight projects. So the installations that you see in this room are about a recording setup where students can record their talks and get fine granular access control access to them, because this is the best thing to get first-hand feedback on when you do a presentation. Then the lab courses, this is something I'm working on since 2003 with different other colleagues that changed over the time. And so I created a very nice lineup of different courses with the MOOC hybrid, with here being the newest edition. We have lots of students at TUM, and so therefore that one I also created a concept, a didactical concept for teaching that is also published here. I created the e-learning system for that, because back in 2004 we didn't have e-learning systems. And the newest one I said is the hybrid here, which is a MOOC, and on the other hand it's an on-site course. And this is an attempt for trying out how can you integrate MOOCs into the regular teaching at a university. And the way we do it here is very helpful and very efficient. Okay, and there's also the online course that's currently running, where we have more than 1,500 participants at the moment, or people that enrolled. Teaching was always evaluated at the beginning by myself, because I always was curious on how the people are about it, and then also by the Fachschaft here, which is very comfortable, and so the results were always very good. People were very happy about the teaching. There are 2 publications in teaching research. A recent one is about the new format that I created some years ago. And yeah, important part of my teaching, also the PhD students that are also here, mostly in the room. So this is my core team, and this is an external PhD student at Siemens that I also partly co-advised there. Funding acquisition, I also acquired quite a lot of money from different sources. So from TUM, but also from BMWF, BMWI, Intel companies, Siemens and so on, DFH. And yeah, so overall it's more than 800,000 euros, which is probably quite okay. And I was also involved in the project management in different roles. At the moment I'm coordinating a German-Finnish project that is ongoing until the end of the year. Yeah, so that one just briefly. So this is a German-Finnish project. So this is a project in the German-French Academy where we do something with industrial robots. And these are project partners that I was working with for different projects. I was also involved in the BIDT, Bavarian Internet Digital Transformation Institute now, which was before the Munich Center for Internet Research. And yeah, this is the last slide. So I'm also, of course, active in the community. So I'm a co-chair of different conferences, workshop chair, and so on. So I was basically in all the major roles, besides general chair for a huge conference so far. And so this is also something very interesting to work with the community there. Okay, so summing up, so I introduced the data-centric mechanisms that we used, focused then on the teaching here, and also community work, on the research and community as one important thing there. Teaching, evaluated, PhD students, funding, project acquisition experience, and community experience. Thank you for the attention.